So this is from a viewer. They ask, can you do an episode about atom splitting? Now when I saw the topic, my first thought was that I'd have to start with nuclear physics. Then I thought, there's no way I can explain nuclear physics in 2 minutes. So then I thought, well, what if I just tell them that it's impossible? But then I thought, no, let me try. Let's see if I can actually do this. So here we go. We all know that matter is made of atoms. The simplest atom is hydrogen, which has 1 proton and 1 electron buzzing around it. And because the simplest explanation is usually the right one, we can assume that all other atoms are just hydrogen atoms that have gained extra protons and electrons. This is true except for the fact that some numbers of protons and electrons don't work. For example, you can never have 5 or 11 or 17 protons and electrons. There are only certain numbers that work. And here's why. In the old days before quantum mechanics, scientists thought that if you split an atom, you could split it into any number of pieces. It turned out that wasn't quite true. You can only split an atom into pieces that have these special numbers of protons and neutrons. These special numbers are called magic numbers. The most common magic numbers are 2, 8, 20, 28, 50, 82, and 126. If you look closely, you can see that they follow a pattern. You can always add 8 to the previous one, or you can almost always add 14. If you want to split an atom into 2 pieces, you need to find 2 numbers that add up to the total number of protons in the original atom. And those 2 numbers have to be magic numbers. For example, if we take an atom of uranium, which has 92 protons, and we want to split it into 2 pieces, we need to find 2 magic numbers that add up to 92. Well, the closest magic numbers we have are 82 and 20, so we get uranium 235. We also get a few stray neutrons, and we get an atom of krypton which has 36 protons. So we get krypton 82, 36 plus 46 equals 82, and that's pretty much it. Krypton 82 is slightly radioactive, but that's not important. The important thing is that we've successfully split the uranium atom. Now, uranium is not the easiest element to split. In fact, you can't even split it with regular old nuclear weapons. You need to build a special kind of reactor that slows down the neutrons. But uranium isn't the only element you can split. Almost every element on the periodic table can be split except for the elements with 1, 2, 7, or 9 protons. Why? Because the magic numbers don't work. If we try to split helium-4, which has 2 protons, the only possible combination of magic numbers would be 2 plus 2, but helium already has 2 protons, so there's no way to split helium. The same goes for lithium-3. We could split it into 2 and 1, but 1 isn't a magic number. Boron-5. We could split it into 3 and 2, but again, 2 isn't a magic number. And finally, for beryllium-4, we could split it into 2 and 2, but beryllium already has 4 protons. So that's why some atoms can be split and some can't. Oh, and one more thing. You can't split an atom by smashing something into it. You need to capture a neutron. If you smash something into an atom, it'll just bounce off. That's because the nucleus of an atom is so tiny. It's like trying to split a basketball by throwing a marble at it. Now we know how to split an atom, but how do we make one atom become another? That's where nuclear fusion comes in. Nuclear fusion is the opposite of nuclear fission. Instead of splitting atoms, you smash them together so hard that they fuse into one big atom. For example, if we took 4 hydrogen atoms, we could smash them together until they form helium. Or we could take 2 helium atoms and smash them together until they form beryllium. Nuclear fusion is what powers the sun. Here's how it works. Hydrogen atoms fall towards the center of the sun until they're packed tightly together. Then they start to fuse together. For hydrogen atoms turn into 1 helium atom, and we get a few extra protons and neutrons. Technically, this process releases energy, but we don't care about that. What's interesting is that we end up with 1 less proton. So if we started with 100 hydrogen atoms, after the fusion, we end up with 99 hydrogen atoms and 1 helium atom. That's how we went from mostly hydrogen to mostly helium. You might think that's a small change, but it's not. Helium is the second most abundant element in the universe, right after hydrogen. Also, fusion doesn't just make helium. Some of the hydrogen atoms can fuse together to make deuterium, which has 1 proton and 1 neutron. Other times it can make tritium, which has 1 proton and 2 neutrons. And sometimes the helium atoms can fuse to make carbon. All of these elements make up the rest of the stuff in the sun, like iron, nickel, and oxygen. The reason the sun is mostly hydrogen and helium is because those are the lightest elements. Lighter elements are harder to fuse together, but they release more energy when they do fuse. So when the sun was young, it released a lot of energy. As the sun got older and heavier, it released less energy. Eventually it'll get so heavy that it'll stop releasing energy altogether, and that's called a white dwarf. Now we know how to split an atom, and we know how to make one atom become another. Can we combine those two processes to make a time machine? The answer is no. In theory, we could use nuclear fission to power a nuclear fusion reaction, but in practice, it's very difficult to do. Also, we need a ton of energy to start the nuclear fusion reaction in the first place. We can't get that energy from nuclear fission because nuclear fission is too slow. In order to power a time machine, we'd need something really powerful like a star, and stars are really hard to make. In fact, the only star we know of is our sun, so if you want to build a time machine, you'll have to build a star. But hey, it's not impossible. I want to thank my supporters for making these videos possible, and I also want to thank a special supporter for supporting this video. And finally, I want to thank everyone who watches these videos. You guys are the best. There's a link in the description to my website. On my website, I have a full-length version of this video that I wrote specifically for people who like really nerdy stuff. I'll see you next time. Hello, my name is Orta. I'm one of the developers of a software. Today I will tell you about the recent update we did to our software called Atom Split, which allows you to split your atom feeds in multiple formats. The main purpose of this software is to be able to split an atom feed into different formats for different platforms, because sometimes you have a feed from your website or whatever that is only available in atom format, and you want to share it with somebody but they don't accept atom feeds. They want it in RSS or maybe just in plain text. Maybe you have a podcast in atom format and you want to convert it to RSS so that it can be uploaded to a podcasting platform. Or maybe you have an RSS feed and you want to convert it to Atom so that you can upload it to a specific website that only accepts Atom. Whatever the case is, Atom Split can help you. It is very, very simple to use. You just need to paste the URL of the feed or the URL of the site. Well, splitting an atom is no easy feat. It requires more energy than the atom in question has in itself. That's why nuclear fission was such a big deal when we discovered it. It meant that we could split atoms to get more of them. That meant we could make bombs and later power plants. Today, we're going to go over how nuclear fission works, and how scientists have managed to split an atom into two smaller ones without even touching it. Before we can talk about splitting an atom, we need to talk about what an atom is. We won't be going into the details here, but if you want to learn more about atoms, check out the video linked below. To recap quickly, atoms are made up of protons, neutrons, and electrons. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge at all. The number of protons determines what element the atom is. For example, if an atom has 1 proton, it's hydrogen. If it has 6 protons, it's carbon. And if hello everyone, in this video we'll be learning about an amazing man who split atoms for the first time in history. Let's get started. Number 4, the man. Before we talk about how he split the atom, let's take a look at the man himself. Frederick Soddy was born on September 1, 1877 in England. He was a chemist and radiochemist who won the Nobel Prize in Chemistry in 1921 for his work on isotopes. However, his work went far beyond that. He also made significant contributions to our understanding of radioactivity and nuclear physics. One of his most famous experiments was splitting the atom. This was a groundbreaking achievement that helped to pave the way for nuclear energy.